and our b values and how those affected our graphs. You guys said that a meant we were doing what?
Or dividing by y. Or dividing y.
Multiply y.
Oh, yeah.
Multiply y. Okay, and the reason we do that is because a is the amplitude, right? Which is how far away from the x-axis that we go up or down. Which makes sense because y controls up and down. Okay, and then we had our b value, which b value meant we were supposed to be doing what? Dividing the x, right. And the reason we do that is because b controls if I'm moving left and right. My x's control if I'm moving left and right. So that's going to control if my period is its normal 2 pi or if it gets more spread out or comes closer together, right? Okay, so in addition to multiplying and dividing our x and y values by something, we might also come across an instance where they're not telling us to multiply or divide them by something, but to literally take all of our points, pick them up, and move them somewhere else. So maybe they tell us to move those points left or right or up or down or maybe both, right? So in those cases, you would find those things happening for left and right shift inside of the parentheses with x. So there's going to have to be a parenthesis with some plus or minus h in there. And because it's inside the parentheses, remember it's opposite of what it would normally be. Remember we normally would take something out of its parentheses and set it equal to 0 to solve for what it really is. So just don't forget that if it says plus a number in there, that really moves my graph to the left, even though it says plus. Because if I took it out and solved, I'd get a negative, right? And if it says minus h, that really means to move my graph to the right for the same reason. If I were to solve, I'd get a positive. And positives are to the right, negatives are to the left. Okay, then for your k value, less confusing. It is not inside of a parenthesis, so it means exactly what it says. Your k value is usually found at the end of the equation. Doesn't have to be there, but it is just some number added or subtracted to your function. If it's added, that's going to move your graph up that much. If it's subtracted, that's going to move your graph down that much. Okay, so let's take a look at this first equation and apply those changes. So it says to sketch the graph, y minus 1 equals 3 cosine of pi fourths times x minus 3. And they give us some bullet points on what we need to be doing here. It says first, solve the equation for y. So if I'm going to graph something, y has to be by itself. And currently it is not by itself. So how could I fix that? Plus 1. Okay, so I'm going to add 1 to both sides. Okay, so now I've got y equals. Now realize I can only add 1 to like terms. None of this is like terms because it's all got a bunch of variables attached to it. So this is like 1 plus 3x. I can't add them, right? So I would just have 3 cosine of pi fourths times x minus 3. And then I just tag my plus 1 on the end. Okay. So then they ask about a horizontal shift. Well, our horizontal shift, remember, happens inside the parenthesis, right? What do we have happening inside our parenthesis here? Right, 3. It says minus 3, and it's opposite of what we would think. Okay, so I'm going to shift 3 units right. Okay? And then my vertical shift, that's k. And what does our k tell us we're going to do on this one? Okay, so 1 unit up.
Is one of them opposite and the other isn't?
Because one of them's inside of a parenthesis and one of them's not. And whenever you're in the parenthesis, you would have to solve. So I would take, remember just like when we solved earlier, you'd take x minus 3, set it equal to 0. It ends up a positive 3 when you take it out. Okay, so we've taken care of the first few bullet points. Next it says, using the parent function points from the cosine function, multiply each x value by blank, and then multiply each y value by blank. All right, so normally we have said we divide our x, right? But when we divide x, we always end up with a fraction divided by a fraction, right? And when we have a fraction divided by a fraction, what do? Multiply by the reciprocal. So, instead of saying I'm going to divide by b, they're saying just keep in mind what you're really doing is multiplying by the reciprocal. Well, what's our b value here? Pi fourths. So I want to multiply by its reciprocal. What would be the reciprocal of pi fourths? 4 over pi. Okay, so I'm going to multiply all my x's by 4 over pi. And then I multiply all my y values by a. And what's our a? 3. Okay. So let's do exactly what they just said. So first I'm going to write down what our original points are for cosine. So at 0, cosine has a value of 1. And then we would be at pi halves, which has a y value of, and then pi, negative 1. And 3 pi halves, good. And 2 pi, good. And now we make the above changes that they asked for. So for my new points, I'm going to put those in this margin over here. So I'm supposed to multiply my x's by 4 over pi. What's 0 times 4 over pi? 0. And my y's by 3. What's 1 times 3? 3. Okay. Now I'm going to multiply pi halves by 4 over pi. So my pi's are going to cancel out, right? And then what would be left? 2, right? Because the pi's canceled out. We'd be left with 4 over 2, right? And then 4 over 2 simplifies to 2, okay? And then my y value, 0. 0 times 3 is 0, okay? Pi times 4 over pi. Well, again, the pi's are going to cancel out, so what's left? 4. And then negative 1 times 3? Negative 3. Okay? Then 3 pi halves times 4 over pi. Again, my pi's cancel out. What are we left with? 6, right? Because we'll have 4 times 3 in the top, which is 12, over 2. And what's 12 divided by 2? 6. All right? And then 0 times 3 would still be 0. Okay. Then 2 pi times 4 over pi. Again, my pi's are going to cancel out, so I'm left with a 2 and the 4 in the numerator, which would give me 8. And 1 times 3 is 3. Okay. Now, it says that we also had a horizontal shift and a vertical shift, right? Okay, so that would mean that I either would need to, if I'm moving to the right, my numbers would be increasing, right? I'd have to go add 3 to every single one of these x values, which I could do. And I was told that I'm going to move up 1, which would also be an increase, right? So I'd go add 1 to all of my y's, which I could do. But it also says that instead of doing that, they give us this helpful little trick that you can just graph these points that you came up with on translated axes. So basically what they're saying is move your x and your y axis by however much they said to. Well, they said we were going to move right how many? 3. So instead of being here at 0, I would move to the right 3. Well, my x-axis is in terms of pi, and pi is approximately 3. Yeah, 3.14. So we'll say that pi is approximately 3. Okay? So I would move from this being my y-axis here at 0 all the way over to here at pi, because that's approximately 3. Okay? And then they said instead of staying on the y-axis on the x-axis 0, they said to move up how much? 1. So I'm going to translate my x-axis up here to 1. So now I'm going to go plot all of these coordinate points, but I'm going to pretend that this is 0, 0 when I do that. Okay? So if that is 0, 0, then some things to keep in mind would be that 2 pi is basically like my new 3, right? Because from that over is equivalent to 1 pi, which we said was about 3. Okay? And if that's 3, then we know that this would be approximately 1.5, right? So hopefully that helps us when we're trying to go plot these points. Okay, so my first point says to plot it at 0, which means don't go left or right any, 3. So this is my new origin. I'm not going to go left or right any, just up 3. So this would be up 1, right? This would be up 2. This would be up 3. So I'm going to go to here and plot my first point. Okay, the next point is at 2, 0, right? Okay, well, we said where 3 pi halves is approximately 1.5. So 2 would probably just be one line past that. And it said don't go up or down any, right? Just plot it at 2, 0. Okay, then I'm supposed to go plot a point at 4, 3. Well, if this was 2, then move the same distance over, and I'll be at 4. But it said to move down 3. Okay, well, this is, remember, kind of like my 0 now. So this would be -1, -2, and -3. So I'd be down here. Okay, my next point is at 6, 0, but is that going to fit? Okay, so I'm going to go back the other direction. But remember, our graph is continuous at this point, right? So it's going to have a mirror image of the points I just plotted going this way. So when I had this point here, I should have another one right over here at the exact same spot. So right here. And then same with that point that was down low, right? I should have another one in the exact same spot. So right about here. So if we go connect our points, it looks something like this. Oops, it didn't like that. Okay. So you've got 2 ways of thinking. They suggested that we just go ahead and move the axes, which is going to be pretty helpful, especially if you start to get big numbers. Like if they told you to shift right 15, you aren't going to want to have to add 15 to every single one of these numbers, right, when you're counting. So if you'll just go ahead and move your axes, you would be fine. You wouldn't have to count it out, okay? But if you want to double check yourself, you can always add or subtract the right amount to your new points and start from your regular origin if you prefer that. Okay, so now that we have it graphed, my domain. So this graph is repetitive, right? That's what we said. It continues. So is it ever going to stop going left or right? So what's our domain? All real numbers. Good. Okay, and then my range. Now remember, we edited this graph a little bit, but we only drew those darker lines on there to help us, right? If somebody just came and saw your graph without all of your extra markings, just remember that they would see these normal numbers, right? They wouldn't see this or any of those extra markings we made, right? So that's what they're asking. If somebody were to just look at the normal graph, what would they see for your range? -2, yes, all the way up to +4. Good. So from -2 to +4. Good. Okay. Then my amplitude. Well, remember, amplitude is how high or low you went from what you consider your x-axis, right? So for us, we considered this line our x-axis. So how far up did we go? Okay, and how far down did we go? 3. Those should always be the same. If you ever get different numbers, you know that you were looking from the wrong spot because they should always be equivalent. If you go up some amount, you go down the same amount.
So only for our amplitude we're using that, right?
Yeah. Yep. Because that is the line that already included the shift that was also made in the equation. All right.
But if you didn't draw the lines, you just plot the points, how would you do it?
Then you still would be keeping in mind, oh, I also was shifting up 1. So I need to remember that wherever I say I'm ending up,
I can just subtract.
or if you're talking about how far you went down, you'd add 1. Okay. All right. And then for the period, that's how long it took to make 1 full cycle, right? Okay, so we started here, ended here. So again, this would mean that you're going to have to think really hard about, since this is in terms of pi, exactly how much that moved. Or, if you don't want to have to think that hard and count it out on the picture, we've got a formula that'll do it. Okay? So if we're looking for the period, then you could just manipulate this formula. Your period would be equal to 2 pi over b. And what was b in the equation? Pi fourths. Okay, now we don't like a fraction in a fraction, so what are we going to do? Multiply. So 2 pi times 4 over pi. And those pi's will divide out, right? So what's the period? 8. So totally your choice. You can either come over to your graph and physically count how far it is, and you would have gotten 8, or you can mathematically solve it and get 8. Totally your preference. All right? Yeah. Okay. Let's look at one more. Flip it over on the back. So we need to follow the same steps that they told us to do on the front. So the first bullet point, remember, said, if necessary, you need to solve for y. Do we need to solve for y here?
Yes.
Yeah, what am I going to do?
Subtract 1/2.
Subtract 1/2. Okay, so I'm going to subtract 1/2. All right, so then my equation is now y equals -2 sine times x minus pi over 2. And then we got that minus 1/2 on the end, right? Okay, they ask about the horizontal shift. And our horizontal shift, remember, happens inside the parenthesis. So that's this part right here. And it's opposite of what we think. So which way are we moving?
Down. Oh, wait, sorry. Whoa.
Which way?
I was
Right. Okay, so we're going to go right pi halves. Okay? Then they ask about the vertical shift. That's the up and down part. So how much are we moving up or down? Down 1/2. Good. Okay. And what am I supposed to be multiplying my x by? Remember, we normally divide by x. We multiply by reciprocal, right? So what am I going to multiply my x by? Okay, so what do we normally divide our x's by? What value? What did you say? The b. Yeah. So where is b? It's supposed to be right here, right? Is there anything there? So what's it understood to be? 1. Okay. So if I flip 1 over, which is what we would do when we multiply, it would still just be 1, right? Okay, so.
In front of the x?
Yep, right there. Okay? And then we multiply y by which piece? A. And where do you find A? At the front. Okay, so what am I supposed to multiply my y's by? Good. Okay. All right, now they ask a few other things. Some of this we can go ahead and fill in because we already know what to expect. Our amplitude, remember, that's how high or low, so absolute value, right? So what would that be? 2. Good. Okay, and I'm graphing sine. Is it ever going to stop going left or right? So my domain would be all real numbers. Okay, so the only thing that leaves is the range and the period, which we may or may not know until we graph it, right? You can solve for the period mathematically, but if you're somebody who wants to count the period, you'd have to graph it first. Okay, so let's graph it before we fill these in. So, first, just like they had us do on the front, let's list the original points of sine. So sine starts at 0, 0, and then we would have, and then pi 0, and then -1, and then 0, right? Okay, so now let's do exactly what they said and multiply our x and our y's by the correct values. So what did we say we were going to multiply x by? 1. So is that going to change any of our x values if we multiply by 1? Okay, so the x values all stay the same. 0, pi halves, pi, 3 pi halves, and 2 pi. And what are we multiplying y by? -2. All right, so 0 times -2 would be 0. 1 times -2 would be, and 0 again would be, and -1 times -2, +2, and 0 would be 0. Okay. All right. So now I'm going to do exactly what they suggested to us last time. We're going to adjust our axis. So we said that we were going to shift to the right pi halves, right? So I'm going to come over here, and instead of having a y-axis at 0, my y-axis is now over here at pi halves. Okay, and they said we were going to shift down how much? 1/2. And it looks like they have these lines marked at a half per line, so we would just go down 1 line, right? Okay, so remember, we just made some changes, right? We just moved some things over, but I'm treating this like my new origin. So this point where I'm at is basically like my 0. Well, if that's 0, then pi would basically be like pi halves, right? And 3 pi halves would be pi. And 2 pi would be 3 pi halves, and so on and so forth, right? They've all been scooted over 1 line if this is my new 0, 0, my new origin. Okay, so just something to keep in mind when we go plot our points. Okay, so my first point is going to be where? Yeah, so at this new origin. I don't go left, right, or up or down. Okay, the next one is supposed to be at pi halves, so I'm going to go over to where it was used to be pi, right? But now we're saying it's pi halves. And I'm going to go down 2. Well, if each line is worth a half, how many lines do I have to go down for 2? If each line is a half, how many lines do I need to go down? How many? 4. So 1, 2, 3, 4. All right? Then it says to plot a point at pi 0. Well, pi is where 3 pi halves used to be. So I go plot a point right here. And then it says we're going to plot a point at 3 pi halves. Well, that's where 2 pi used to be. And you guys said to go down 2 meant to move down 4 lines. So to go up 2 must mean to go up 4 lines. Okay? And then that last point is 2 pi. So how many more lines over would I need to get to be at 2 pi? 3 lines over. And I'm at 0, right? Okay, so let's connect those points. So our graph looks kind of like this. Okay. So now we can answer what they had asked about range and period. So what was the highest our graph ended up going? Well, that was right here. And where would that be? 1.5. Okay, and what was the lowest it ended up going? Negative 2.5. Okay, so we would say it's between negative 2.5 and 1.5. Okay, my period. They're asking us how long did it take us to get from our first point to our last point? 2 pi, right? We just picked the whole graph up and scooted it over pi halves, but it was still 2 pi long. Very good. So this would be 2 pi. Remember, you can also solve for that mathematically. If you can't see it, you would just use this formula but manipulate it. So your period would be 2 pi over b, and we said b was 1, right? 2 pi over 1 would still be 2 pi. All right. So now we know how not only to vertically or horizontally stretch and compress, multiplying by a and b, we also now know how to shift things vertically or horizontally as well.